Google just dropped their new Gemma 4 QAT models, making local AI more accessible than ever before. Specifically, the E2B variant features 4.6 billion total parameters, but only activates 2 billion at a time. It made me wonder, is it possible to run this lightweight model on a budget CPU-only system and still have it reliably manage our home assistant devices, like toggling a smart outlet? To put this idea to the test, I didn't want to just talk theory. I actually went out and rented a budget VPS with a pretty basic setup, 4 vCPUs and 16 gigabytes of RAM, with absolutely no GPU acceleration. Through Docker, I installed Ollama and deployed the local Gemma 4 E2B model. After a quick setup, I did a basic sanity check and typed which model you use. To my surprise, it actually ran. Looking at the logs, the response speed was around 6.9 tokens per second. While that's about 3 seconds faster than the Gemma 4 E2B model we tested previously, it still feels a bit slow. But remember, this is a virtual private server, not bare metal. This means low-power hardware that most of you use for Home Assistant, like a mini PC, an old NAS, or even a Raspberry Pi, can absolutely host its local model. Since the model is running, step 2 is connecting it to Home Assistant. Just head over to Settings, click on Devices and Services, and add a new integration. Search for Ollama, type in your server's access address, and since we didn't set up an API key for our local instance, we can just leave that field blank and submit. Now, let's test the core conversation agent. We'll click Add Conversation Agent, give it a custom name, and select our E2B model. There are a couple of crucial steps here. Make sure to check Assist and enable Think before responding. Keep everything else at default. Next, let's create a voice assistant in Home Assistant and set its conversation agent to our new Ollama agent. Opening up the chat window, let's start with a straightforward command to see how it handles explicit details. Turn off the smart plug with the entity ID switch.smart_plug socket. Because of the low-end hardware, there was a noticeable delay and the loading wheels spun for quite a while, but incredibly, it worked on the very first try. Since that went well, let's turn up the difficulty. This time, I'll use the friendly name. Turn off the smart plug with the friendly name bedroom socket. It passed that too. Let's push it one step further with an alias. Turn off the smart plug with the alias name bedroom socket-1. Surprisingly, it executed successfully again. However, I have to be completely honest here. After testing this multiple times, it does have a noticeable failure rate. It's not 100% reliable. With basic chat control working, let's see how it handles an AI task. We'll head back to the Ollama integration page, click on Add AI Task, and use the same settings as before. Next, let's jump into the Developer Tools under the Actions tab and choose Generate Data. To test its vision and structured output capabilities, I'm going to pass it a custom prompt, asking it to describe the image and output true if there's a person and false if there isn't. We'll select our AI task entity, provide a structured output template, upload a photo containing a person, and hit Perform Action. After a brief loading screen, it actually spit out the correct result. Not bad at all. But things couldn't stay this easy forever. Let's test a popular custom integration, Extended OpenAI Conversation. As we've seen in previous videos, this integration has built-in tools that allow the model to directly control our smart home devices. The setup is similar. We'll type in a random API key, make sure to check Use Tools, and submit. Now, opening a fresh conversation window, I sent the exact same commands we used earlier. I tried it multiple times, but none of them worked. They all failed. I did some digging into the Ollama logs to find out why, and there was the culprit, a clear error saying tool call parsing failed, unexpected end of JSON input. It turns out this E2B model simply isn't powerful enough to parse JSON tool calls properly, even though the heavier Gemma 4 E2B model handled this test successfully. This is where the limitations of a 2 billion active parameter model really start to show. But we're not about to give up that easily. If native tool calling is failing, can we bypass it using a custom skill? To find out, I had an AI write a custom Open Web UI skill specifically designed to turn devices on and off, and I pasted it into the skill input field. I also had the AI write a companion tool code, pasted that in the skill input field, and linked both the skill and the tool to our E2B model. Now for the ultimate test. Entering our prompt again, something unexpected happened. On the first test, using an explicit entity ID, it passed. On the second test, I asked it to execute 2 tasks at once, turn off the light and plug, using their specific entity IDs, and it handled that smoothly too. But the moment I tried using a friendly name or an alias, things stalled. Looking closely at the model's thinking process in the logs, it actually successfully found the correct entity ID, but for some reason it just couldn't trigger the actual execution. After a series of unscientific but highly practical tests, Gemma 4 E2B achieves almost the same results as the E2B, just with a slight edge in raw speed. By the way, I've put together a document summarizing everything from this video and all of our past videos, link in the description. What's your take? Is Gemma 4 E2B actually ready for budget smart homes? Let me know in the comments. As always, your likes and subscribes keep me going. Thanks for watching.